I'm going to do complex numbers and roots. So before we did all of the real numbers, which was a group that had inside of it rational and irrational, and inside of rational were our whole numbers, integers, natural numbers. So we have all that information, but this isn't actually the biggest set of numbers. The bigger set of numbers is actually going to be complex numbers. And we just didn't talk about this before. So now we're going to put complex numbers in here. So there are a couple of different things that we can have. We can have all of the reals, but we can also have numbers that are in the form of imaginary numbers. Or just complex numbers on their own are going to be a separate set as well. Imaginary numbers are anything with an I. So I, 7i, anything along those lines. They're going to be imaginary, and we'll talk about that. Complex numbers are when it's 3 plus 4i. A number plus an imaginary number. That's a complex. So we're going to look at those two different kinds of examples in a little bit. Okay? So a complex number first is made up of two parts. It has a real part, which is, they call it the a value, plus, and it can be minus, an imaginary part, which is, they call it b times I. It'll always have an I in it, okay? Now I write my I like a backwards J, so just so it's really easy to tell that it's an I. So it's super simple, okay? So this is an imaginary number. It's made up of the real, or sorry, a complex number. It's made up of the real and the imaginary. Okay? So we'll solve for this sometimes. We'll solve for it. Find the zeros. And I give you this function right here. So I'm going to do this by completing the square, which we've already done. So the first thing I'm going to do is I'm going to trap the x's. Well, I'm going to set it equal to 0 because it tells me to find the zeros. I'm going to drop an x from both. I'm going to divide by 2. I'm going to square it. I'm going to get this alone. When I squared it, I actually added something to this side, so I need to add that to the other side. So -1 squared is 1. There's no number out here, so it's just times 1. So I've added 1 to this side, I have to add 1 to this side. Now I want to get this alone, so I'm going to subtract the 5. Now I square root, and I can't do the square root of a -4, but I actually can. So the square root of -1 equals imaginary. So what I'm going to do here is I'm going to break down -4 into the square root of -1 times 4, or the square root of -1 and the square root of 4. The square root of 4 is easy. It's 2. The square root of -1 is also easy. It's I. So this is both a positive and a -2i. Whenever you do a square root, it's got to be positive and negative. So it's going to be positive and -2i equals x minus 1. Now I add 1, and my answer is 1 plus or minus 2i. And this is actually two complex numbers, 1 plus 2i and 1 minus 2i. The i's will always be additive inverses, so if you have one part as a complex number, you know that this also has to be a complex number. Always, every single time. So that's what we're looking at. That's about it. You're just putting in the element of an imaginary number as well. Okay? So I'll do another example right here. We're going to solve this. So the first thing I'm going to do is I'm going to trap the x's. I'm going to drop an x from each. I'm going to divide by 2. I'm going to square it. When I square this side, I've added 9 to this side, so I have to add 9 to the other side. I'm going to isolate the variable by subtracting 34. I'm going to square root. Square root of negative 25 is the same thing as the square root of negative 1 times 25, or the square root of negative 1, square root of 25. Square root of negative 1 is I. Square root of 25 is 5. Whenever I do square root, I put a plus and a minus. Now I'm going to subtract 3. So my answer is going to be x equals negative 3 plus and minus 5i. The two complex numbers here are negative 3 plus 5i and negative 3 minus 5i. These always come in multiples of 2. Always. If you have an imaginary number, it has to be in a multiple of 2. And that's it.